All right, so let's get started. So here's your final practice. So you're going to complete each of the following. It's graded in the following way as always. So just 1 point for attempting it, 3 points for processing, and 1 point for the correct answer. So this is the written part. So if I cared about the right answer, it's in the WebAssign part. If I wanted to see you work through the process, that's why it's in the written part. Okay. All right. So therefore, if you just write down answers, because let's be honest, you can just type this in Wolfram Alpha. It'll pump out what the answer is. It's just not worth that many points. So let's do this. So here I have a limit. Notice here, if I plug in -3 in directly, I'm going to get +9 -6 -3, which is 0. And so I can't just plug it straight in. So I'm going to have to do some algebra for this one. And so here the limit as x goes to -3. So what do? We just go ahead and split this apart. So this is x plus 3. This is x minus 3. So this factors in this, and this down here factors into x minus 3, x plus 1. Let me double check that real quick. Yeah. And so here, notice here, I can cancel these two out. And then here I have the limit of x minus 3 of x plus 3 over x plus 1. Here, I can just plug it straight in. Now I can plug it in. So this is the same thing as -3 plus 3 over -3 plus 1. And this is equal to 0 over -2, which is equal to 0. Okay. And then, of course, I'm going to show you how to check it into Wolfram Alpha. So let's do that. So let's look at Wolfram Alpha. So here I'm just going to type in limit. And here you can just use one of these as a template. And then we're just going to type in. So x in here is going to go to -3. And then we're going to type in from here. And just type in the original. Type in the original. That way you're not worried if you got your algebra right or wrong. Oops. I want to put that in parentheses. Maybe. Plus 2x minus 3. Yeah. Let's make it look right. 3/2. That means I did something wrong. Did anyone see what I did wrong? That's a good question. Isn't it x plus 3? Hold on. That isn't factored out correctly. You're absolutely right. This is why we check it in Wolfram Alpha. My dyslexia got me. Let's go back. This is x plus 3, x minus 1. Now if I check this, right? All right, so here we go. So we have the x plus 3 cancel, so I have x minus 3, x minus 1. So this becomes -3 over -2. And here I get -6 -2. I still get the wrong answer. Oh boy. Do you ever have days you're thinking, maybe I shouldn't be a math teacher. Maybe I should go dig ditches. that's where I'm at today. I typed this in right. Yeah, so I should get 3/2. And yet I'm not.
Professor,
Yes.
it's -3 minus 2 minus 1, and you put -2.
Oh, yes, -1. So that becomes -4. Thank you. Which becomes 3/2. Sorry about this. I can't even do my first problem in my exam. All right. Any questions at this point? This is why we check it in the calculator. Oh boy. I should have done these beforehand. Any questions on this now? It's all good. Thanks. All right, let's do the rest of them. All right, so here we're going to do the first derivative of this. We're going to use the definition 2.2. And what definition is that? Let me show you. Let me open it up and do it. Hi. Let's go to my 2.2 notes. Get notes. 2.2. Yeah, please. There we go. So I mean doing this right here. Okay, so remember how we did this? Calculate the first derivative, and we did it by crunching through this right here. So that's what I mean. We're going to use this derivative definition for a derivative. So let's do that. Hi, go away. You. Oh man. All right, so let's do that. So here we have the limit is equal to, as h goes to 0, of f of x plus h minus f of x all over h. And so in our case, this would be a g of x, I suppose. So we'll have negative of x plus h plus 2 minus the square root of x negative x plus 2 all over h. Okay. Now, do you remember how we solved this one? Does anyone remember how we solved this one? We're going to do something plus something. We're going to multiply by a 1 here. Does remember what the 1 was? Yeah, it's the conjugate. So here we're going to do negative x plus h plus 2 divided by a square root of minus x plus 2. And so the same thing here, the square root of negative x plus h plus 2 over this. So what have I multiplied here? I multiplied by a 1. But if I multiply this up top, what do I get? I get this times this. And so it'll be this squared minus this squared. Well, this squared is just minus x plus h plus 2 minus x. So minus the minus x. So let's go ahead and make that plus x minus 2. And let's go ahead and distribute this negative as well. And so if we distribute the negative as well, we'll have minus x minus h. This is a plus. All over h times the square root of negative x plus h plus 2 all over plus 2. Okay, so what do we? So this cancels out this. This cancels out this. So I have a negative h on top and an h down below. And so those h's cancel. So I'm just left with a negative 1 up top. Oops, hold on. I forgot something, didn't I? You need to write each goes to 0 because we still haven't taken the limit yet. Okay. And now that I can cross off the h on top and bottom. Hold on. So here, what am I left with is negative h and an h. So I can cross off h and the negative h because that's all that's left. And this becomes negative 1 up top. And so now I can take the limit. I can do that And then here I'm going to do is square root of minus x plus 0 plus 2 plus square root of minus x plus 2. And so that's going to equal to 1 over, or negative 1 over 2 minus x plus 2. Okay. All right, now how do we check this? Well, we just take the derivative, right? And here I can just take the derivative real quick and just do this right here on the side. So here I have minus x plus 2 to the 1/2 power. So the 1/2 comes out. This goes down by 1, so I have minus x plus 2 to the minus 1/2 power times the derivative of the inside, which is just negative 1. Well, if I rewrite that, I get negative 1 up top over 2 square root x plus 2. So that works out. Now let's check it in Wolfram Alpha. Let's check it in Wolfram Alpha. And so here, to check a derivative, all we have to do is type in d dx. Then we just type in what we need here. And so here we have sqrt is how you type in a square root, minus x plus 2 plus 2 and here we go. And they swapped this for whatever reason, but this is equivalent to ours. And so we're good to go. All right. So let's do the next one. So the next one is we want to find a local min and max value and the absolute extreme values for the following on the given interval. Okay, so to find the local min and max, so we're first going to take the derivative of this. And in order to take the derivative of this is product rule, right? So we're going to call this f, we're going to call this g, right? And so f, well, I guess that's terrible notation. Here's a question when it comes to teaching. So I wrote f of x here. And so if I name this f and this g, that's terrible, but that's what you guys are used to. That's fine. I think you guys get the song and dance. I'm just going to go f prime, which is this, will be this held constant. So it'd be x and the derivative of this. Well, the derivative of that is just 1 over 2 square root or negative 1 minus x plus 1. The derivative of this, well, this one's held constant, 1 plus 1 minus x. Okay. And you can also check your derivative in Wolfram Alpha. And at this point, I would check the intermediate step. I just would. So I just put a little x here, put a little sign here, and then this is x. Okay. I see what they did here. I see what they did here. Does this look like ours? Well, not quite, right? But what they did here is they multiplied this by 1 over x over 1 over x. And so then you'll get, then here you'll get the x will come out. So yeah, so this is what they get. So notice here that our solution looks different than their solution. Is that bad? Not necessarily, right? Are these equivalent solutions? The answer is yes. And let me show that to you. So here, let me see if I can produce the answer they got. So what do I want this to look like this, right? And so they put it all together. And so I'm just going to multiply by square root 1 over x. You do not need to do this, but I just want to show that these are equivalent. And actually it's a 2 on the bottom, so I'm going to multiply by a 2 and a 2 as well, okay? So I'm going to multiply by both of these things. So what we have up here is we'll have minus x over 2 over square root 1 minus x plus, here would be 2 times this would be that squared, so it would be plus 2 minus 2x all over 2 over square root 1 minus x, and this is equal to 2 minus 3x over 2 square root 1 minus x. Okay, so if I'd done that transformation, it looks exactly like it does here. Okay, now is it okay to leave that here? Yeah, that's perfectly fine. It's 100% fine. All right, so what's the next thing? So we found the derivative. We set it equal to 0. So we have 2 minus 3 minus x equal to 0 over 2 over 1 minus x. Okay, so we set it to equal to 0, and we also set it equal to what? What's the other thing we set it equal to? Does anyone know? We set it equal to 0, and we set it equal to something else. Yeah, undefined. So undefined, right? So so in this case, if it's 0, it means the top part was 0. So that means that 2 minus 3x is equal to 0. If this is 0, that means the bottom part was 0. That means 2 times the square root of 1 minus x is equal to 0. Okay? So this should tell me that x is equal to 3 halves, and x is equal to that over, square both sides. X should be equal to 1. Yes. 1 here, that's 0. 3 halves here, I get minus 2, so that's 0. Okay, so we have these 2 points. So we want to find the local min and maxes. So here we have this. Now there's a couple ways. How do I tell if this is a local min or max? There's 1,002 ways to do it, right? I could take the second derivative and figure out what it is, right? I could graph the thing and just look at the graph. And so any way you decide to do this is perfectly fine with me. I'm going to show you a graphical method just because you've gotten very used to the other way. Let's just look at the graph real quick. And so we just go into Desmos. Hi. Let's use Desmos. Desmos, because I kind of want to graph it anyway for you guys. Desmos. I want to graph x times SQR. SQRT should automatically make what I want, minus x. And so here I have this. And just for my own sanity, I'm going to show you x equal to 1, and then x equal to minus 1, because that's the interval. Okay. So let's look what we have here. So here at 3 halves, we actually have the local max. Here at this is kind of a local min, right? Because it crashes in here. Actually, it's undefined after this. And then here we have another. And so let's look at the graph. So we have the graph here. So it comes up, it hits the point and goes down. So this is our graph. And so we know this is a local max. We know this is a local min. Okay. So this is local max, this is local min. But and then we also want to know what our extreme values are. Well, here, this is 0, right? So this is local max. The function value at 1 is 0. The function value here, well, we'll just type it in, right? I don't expect you to do square roots of 2/3. I just don't. So just use a calculator. So, or 3 halves, sorry, 3 halves. I'll just type in 1.5, it'll be faster. 1.5. Oh, sorry, I have that backwards, don't I? I have this backwards, don't I, guys? Is this 3 halves? No, this is 2/3. That's 2/3. If I solve this correctly, this is what? 2/3. Because you move over the 2 and then divide by the 3. Oh man, it is just not me day. That's okay. 2 divided by 3 SQRT of 1 minus 2 divided by 3. This is approximately equal. Well, let's just use the real result. So it's 2 over 2/3, or 2 over 3 square root 3. Sorry. So this is the function value of 2/3 is 2, 3 square root 3. And then what we want to do, we want to find the absolute extreme value. So we need to test our endpoints. We've tested one endpoint. We've already tested this endpoint. That endpoint's right here, right? And it's 0. The other endpoint is at -1. So f at -1 is equal to what? Well, f at -1 is -1 square root of 1 minus, or 1 plus 1. So this should be minus the square root of 2. Okay. So we get minus square root 2. And does that match what we see in our graph? Does that match what we see right here? Yeah. So square root of 2 is about 1.41. So that's what we see here. All right. So what are we supposed to answer? So what are we supposed to answer? What's our absolute maximum and our absolute min? So here we have our local max and mins. And so I'll go ahead and box these so I know where I'm at. So here's the local min. Here's the local max. And then here's the other test point. And so this, not only is this the local max, this is also the absolute max. So this is also my absolute max because it's the highest of all these points. Even though this is a local min, our endpoint here of -1 is much, so this is my absolute minimum. So what am I looking for in this question? You need to identify what the absolute max is. In this case, it was our local max right here, and find our absolute minimum, which in this case was one of our endpoints. And for every local max and min, you need to figure out what the value is, or at what x does it occur, and what the value is. Okay. And then you can just look at the graphs to see if it's a local max and min. So how do you approach this problem? Let me just review this real quick. You're going to take a derivative and find your critical points. So these are our two critical points. This is a critical point. This is a critical point. We're going to find the values at these points and determine if it's a local max or min. Okay. Then we're going to test our endpoints. Well, one of our critical point was an endpoint, right? So we didn't have to retest that one, but we did need to test this one, the other endpoint. And then once we know our local max and mins and the values at our endpoints, we're going to determine what's the absolute max and min. And how do you do that? Whatever the value is here is the greatest, right? If this is the highest value, that's the absolute max. And if this is the lowest value, that's the absolute min. And notice it could be an endpoint or it could be a local point, local min or max. Okay. So that's why I chose this problem. That way you can see all of it at once. Okay. Any questions on this first page of stuff? So far, no. Okay, we'll go back to it. Then we can take a sip so you guys can finish writing all that down. I feel kind of, do me a favor, write it on a different sheet of paper before translating it over, just so it's somewhat clean. Or have a scrap paper and then do a clean write-up for the final exam. That way it's easier for me to see things. All right, let's go to here. All right, so let's do this. So we're going to use the midpoint rule to approximate this integral. When you guys do it, you're going to just use the right rule, or you're going to use right. So what's the first thing I do? First thing I do is roughly sketch what I'm doing. I'm going from -1 to 4. Right? And then if I was going to split that up into 5 chunks, it should just be every And so if I'm splitting this up by 5, it just means I'm going to use every whole number. It's going to be right here. So my delta x here is 4 minus a minus 1 divided by my n. So let me write that. Let me actually write down the formulas for you guys. So delta x is equal to b minus a over n. And in our case, it's 4 minus a minus 1 over 5, which is just, of course, 1. So our delta x is 1 unit. We're using the midpoint rule. And so the point I'm going to use, so this is my delta x. The point I'm going to use is negative 0.5, 0.5, 1.5, 2.5, and 3.5. Okay, so I'm going to using the midpoint in order to find my values. And so I'm going to write this is approximately equal delta x f of minus 0.5 plus f of 0.5 plus f of 1.5 plus f of 2.5 plus f of 3.5. Okay. Is everyone clear on how I got to this point? So I'm not asking you to solve the integral, right? Where did the 8 come from? Oh, this is a 5. My 5 got a little too fancy. Thank you. And so for the midpoint rule, we're going to choose the midpoints. If you're choosing the right one, if we were using the right, or if we're using right rectangles, we would be using 0, 1, 2, 3, and 4. If we're using the left ones, we'd use negative 1, 0, 1, 2, and 3. Okay. But now we're using the midpoint rule, so we pick which ones in between. And so I'm using negative 0.5, 0.5, 1.5, 2.5, 2.5. Everyone kind of clear on how to produce this? And this is just 1. And so since this is just 1, all I really need to do is just add up each of these individually. So how do I do that? Well, I just check it through a calculator. It's just a little bit of crunching. So let's just do that crunching. I'm going to have blank squared plus 5, right? That's what I have. And so I'm going to hit, so I'm going to put in minus 0.5. And so I get 5.25. So 5.25. If I put in positive 5, I'll get the same thing, which would be 5.25. So I have 1 times the quantity of 5.25 plus 5.25. Let's just finish the rest of them. So so if I just plug in 1 here, I'll get 1.2. So I'll get 7.25. I plug in a 2 here. I'll get 11.25. And then plus my last one, which is, wait, both negative and positive? Yes. Both my negative and positive are, because I'm squaring it, it ends up being the same number. So if I have a negative number, because it was 0.5 squared, and then minus 0.5 squared, still produces the same number. So yes, this ended up being the last one. And the last one here is 17.25. Okay, and then you just add up all those numbers, and you get an answer. And so I'll have 5.25 plus 5.25 plus 7.25 plus 11.25 plus 17.25. I get 46 point. 46.2, 46, 46.25. And you just put a little box around that. Now, how do you check if you did this right? Well, just take the real integral and see how close it was, right? So let's just take the actual integral here. So I'm going to just do that real quick. So I'm going to type in int. I'm going to put a caret for 4. I'm going to do the underscore for -1. You want to probably put this in parentheses. I'm going to hit x squared plus 5 dx. Something went horribly, 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 horribly wrong. That looks better, right? And we get 4.6675. So this is really, really close, right? So even though we just did just a bad midpoint rule, look how nice and close we are to what the real answer was, right? And so it's a good way of just to see if you're not if you're completely off base or not. Now, is this the correct answer? No, if you give me this, I know you just typed in the calculator, right? And actually didn't perform all that. So do all this. All right, so let's do the last two real quick. So here we're going to use substitution, right? And so we're going to let u equal to 1 minus 60. And then du is going to equal -6 dt. And then so dt is equal to du minus divided by -6. And we'll just plug that in. And so we'll have the integral between 1 over u to the 4th du, and then we'll pull out the -6 just so we don't have to deal with it. Okay, so this integral equals this. After we do this, we integrate this, and so the integration of this is just make our lives a little bit easier. It'd be integral of u to the -4 du. So 6. So this becomes u. So we add 1 up here. So this will be -3, and we divide by the new one, so -3. And then since there's no evaluation, we're going to add a c to it. Okay. So if I just clean this up, I get 1 over 18. And then we plug back in what is u. So 1 minus 6t to the -3 plus c. Okay. All right, now we check it. And we see if I could do this one at least. So here, for the indefinite integral, we'll just get rid of all this. And here we're just going to type in, this is 1 divided by, and I'm just going to leave it as x because that's what I have right here. Oops. I can switch this over to t. So I don't confuse anyone. Oops. Did I finish what I wanted? No. Okay. And does our answer look slightly different? Yeah, I just left it as a -3 instead of putting it back down, right? But here we have 1/18 over this. Okay. So make sure you typed it in correctly and then do that. All right, so let's do the next one. All right, so here, this looks like a big mess, and I wanted to do at least one thing with sines and cosine, and this one looked like the worst one I could find. Just to be honest with you guys. Here, so what am I going to choose? I'm going to let u equal to sine of x. And the reason I want u equal to sine of x, so this becomes sine of u. But I know that du equals cosine of x dx. Because the derivative of sine is cosine, then you add the dx. And so that means dx is equal to du divided by cosine of x. So when I plug this all back in, oops, I forgot to do something. Here I need to find out what is sine plugged in, because I need to, whatever I have here, I need to remove these. I need to move these over. So here I need to put in pi over 2. Well, sine of pi over 2 is, of course, 1, right? And sine of 0 is, of course, 0. So remember, whatever you handle these, if I let this to be my g of x, I need to figure out what g of the upper value is and g of the lower value is, okay? Where g of x is equal to u. So here I need to find g of pi over 2 and g of 0. At least that's how your book writes it. You guys remember doing this? Yes, this is a -3. For those who are questioning my awful handwriting, yes, that was a -3. So this is a -3. All right, so now we can rewrite all this. So here we write it with the new limits, 0 to 1, sine of u cosine of x over du divided by cosine of x. Well, these cosine of x cancels out, so I'm just left with the integral between 0 to 1 sine of u du. Well, the antiderivative of sine is minus cosine, because if I differentiate cosine, or minus cosine, I'll get this, so minus u evaluated at 0 and 1. And if we crunch through that, I'll get, hold on, let me do this. So I'll get minus cosine of 1 minus a minus cosine of 0. And so this should be minus cosine of 1 minus, so it'll be plus 1. And then we just check it in the computer. All right, let's type this awfulness in. So it'll be cosine x sine, so cosine x sine of x. It's struggling. Come on, Wolfram you can do it. Okay, so they go back and they solve it, but since we had values, let's put them in. So this would be pi divided by 2, and this was 0. I forgot. Put those in. Thank you. Thank you so much for your your contribution. So that gives me a number. Well, is that what I calculated? No, but so it gives me 0.56777. Let's just type in negative cosine of 1 plus 1. Oh, look, those numbers are the same. Okay, so we actually did better than the computer, right? We actually have an exact value, and the computer's like, I don't know how to do this, right? And so it just crunched out a number. And so this is correct. And so you just go ahead and put a little box around this. If you gave me the exact value, I wouldn't be mad, right? Just put a little box around this. Go ahead and put boxes around your final answer so I know what to do. And that's it. Okay, so that's your final.